I received this braids micro oscillator from Mutable Instruments from someone who told me that he was swapping the module from one rack to the other, and I'm not sure, maybe there was a power issue and the module didn't work anymore. Others did, but this one stopped working. So I said, well, send it in and we'll see what we can do. The good thing about Mutable Instruments is that everything's open source, so we can get schematics out and see what we can find, which makes it a lot more easier to troubleshoot. The goodie is gone. Well, the first thing to notice is, I'm not sure, the red stripe should be on this side, but it's actually on this side. So maybe this is a very easy repair and just, but we don't know what happened. Maybe he took it out, plugged it in just to send it to me, and this was not on the module when he tried it, so let's leave that out for now. If there was a problem with the power, maybe what got overloaded, and it's probably an easy fix, because the power section, you always hope it's the power section. So what I'm going to do first is I'm going to check for shorts in the power rails. So first for like really short shorts. There's nothing here. Let's see how much resistance there is between ground and plus 12. 3 million ohms, the other way around. 6 million ohms. Now between power and minus 12. 8K should be enough. The other way around. Not measuring anything. Okay, that's funky. So let's give it a quick try. Turning it on. Should be safe. This is the Mutable module tester, so this should match up very well. Let me turn off the power first so I can connect this plug. The red stripe, minus 12, it also says on the back. And now for the power. And here it is, turning on. I actually think there's nothing wrong with this module. It's just the power cord in reverse. Let me plug in the speaker. There's nothing wrong with this module. I was actually hoping for for a real problem, because I was looking forward to troubleshoot this one, maybe do a real repair and try to replace some power components like voltage regulators. These were a little on the loose side, so let me. Yep. I think I'm gonna send a message to verify that that was really the problem, that it wouldn't turn on, because all it needed was to have the power cable. First I can double check his power cable. Maybe there's a problem with his power cable. I have something for that. Maybe it's got a short. So this side of the connector, not sure you can see this. The first row of the connector is connected without shorts. The other row connector is connected without shorts. One extra thing that I can do is to see if there's really nothing strange. I have my lab a bench power supply here. And I made this adapter board where I can connect on these headers the -12 ground, +12, or either 5 volts, and it jumps to because I'll show you in a minute. It has banana plugs in the front, like all lab equipment does, mainly. And this makes it easier for me to plug it to the module, but on the power supply I can check the power used. So I have a preset. And I can create plus and minus 12 volts and ground. Like this. Now I'm just this is the ground connection. This is the -12. And this is the +12. Check, check, double check. -12, +12. I can safely connect the module. And here it is. It's drawing 17 milliamps on the plus rail and 95 milliamps on the minus rail. There's absolutely nothing wrong with this device. So, well, I guess that's what happens sometimes. He was actually very lucky that there's probably reverse polarity protection on here, which actually saved the module from real damage, because the flat cable was just connected the other way around. So I'm gonna shoot him a message, see if this was really the problem. Are you going to charge for something like this? That's a tough question. Yep. Well, let me think about that. I have another repair coming up. I have a Turing machine that doesn't want to do the Turing stuff. So that's a real problem, and involves some real troubleshooting. So I just went to the website where I met this guy, and the story was that he changing case, whatever, and he plugged in the module, and the fuse of the case blew. And he was like, "Oh shit! Oh!" And he changed the fuse, and then he noticed the braids was not turning on anymore. Well, there's a likely scenario. The reverse polarity protection on this module is very simple. That when you reverse the power, it actually sinks it to the opposite rail, so you get a lot of current going through the module, but only on the power side, to protect the module itself. But the fuse of the power supply obviously couldn't take it and blew, and thereby saving everything connected to the devices, to the supply. What I want to do before because this is obviously the problem, well, obviously it's so likely, but I do want to check all the functions for this module before I say that there's nothing wrong with it, because there could have been some sort of damage. So I'm just gonna connect some signals, some modulations, check if all the inputs work, and the output. Well, we already tested the output, and as long as that's okay, then it should be no problem, and we can send it back to the owner. So that's what we're gonna do. And I'm actually curious to how much current is flowing through these diodes. It's probably with diodes, but in a certain way that you don't get a voltage drop when you reverse the polarity. Yeah, I'll probably find a schematic and show it on screen. Anyway, maybe I'll do a test later to see how much current we're talking about that blew the fuse. I don't have a braids myself. I did have a plaits for a while. Oh, trigger seems to work. Let's give him some. Let's give him some FM. I'm not sure when I'm FMing the input if it's supposed to be flickering like that. Can you see that? CV on the timbers. FM is actually scrolling through, but maybe this is the alternate firmware. I'm not sure. Oh, seems to be just fine. Yeah, shame. I'm really looking forward to take this one apart. There's actually not much to mutable modules. They're really nice, really well designed. Yep. So what I found here is the mutable schematic, and let me see if I can find the power section where power comes in. These are all capacitors for the ICs. Bootloader, mini JTAG. Ah, the other page. And here it is. It's actually just a series diode from pin 1 and 2 on your flat cable connector, if you apply minus 12 volts on pin 1 and 2, which you shouldn't, there's actually nothing going to happen because this diode will prevent current running the other way. And the same goes for pin 9 and 10, which is normally your minus 12 volts, and it can only go through the diode in this direction. So if you reverse it, nothing will happen. There will be no current used. So why, though, did the fuse for the rack blow? Let me try this on the breadboard and see what happens. I think nothing happens because there's no way current's running anywhere. So give me a minute, I will breadboard this out and we'll see what happens. Alright, what do I have here? And I hope this is clear on the camera, but I'll try to do the best that I can. I have my black lead to the power supply, which is the ground. We have it all on our bus boards, or 0 volts if you prefer. The red wire is the plus 12 volts and the blue wire is the minus 12 volts, like on every Eurorack power supply and every AC capable audio device mainly. The red wire is giving the 12 volts and is going through the diode, and the diode can only pass current in one direction. It's this direction. It feeds this bus bar, goes through the LED resistor to not make the LED completely burn out. It's a 1K, and the resistor returns to ground, so the circle is complete. On the minus 12 volt version, it's the same. Power comes through here, minus 12 volt. This diode is obviously in reverse because the current is actually going the other way because it's a minus rail. So this is all exactly the same. Current going through the resistor, through the LED, and then returns to ground. Or in this case, it goes the other way. So when I apply power, I give power to the plus 12 rail. Well, this is strange. Wow. The grounds are connected together. When I just give power to the plus 12 volt rail, it actually powers the minus rail. What the? That's interesting. And now I give power to the... Oh no, it's actually the other way around. My confusion. On the power supply, channel 1 is minus and channel 2 is plus. But to me that's actually not so, but it's something that I have to do with the way you wire it up to make it a dual rail power supply. But okay, the plus rail turns on and off, and the minus rail turns on and off. And each of these rails use like 10 milliamps. It's just pretty spot on with 1K resistor and these normal LEDs. So what would happen? We have 10 milliamps on each rail, and what happened on the braids module was that these two rails were in opposite. They were swapped around. If you swap the connector, you connect minus 12 to the plus 12 volt rail, and you connect the plus rail to the minus rail. So what happens if you do that? You obviously get no LED, but also you don't get any amperage, nothing at all. That's what I would expect. There's no power use in here. nothing. And it still all works. So it leaves me quite baffled how the fuse of the rack could have blown. Was it a coincidence? Was it actually maybe that the connector was not only reversed but also like one pin lower, where you connect maybe the minus or the plus real 12 volts to either of the grounds? What happens if I just short this one to ground? Then my power supply is limited to 1 amp, but it immediately jumps to 1 amp. And the voltage drops to 100 millivolts. So that's a likely scenario. If I do it with the minus real, it also immediately jumps to an amp. I can try to see, yeah, well, it will probably take 3 amps if we raise it. That's the maximum that power supply can do. So I have a maximum power use of 3 amps on the plus rail, and if I put it here, it actually sucks it on minus rail. Oh, sorry. Let's try that again. Yeah, it's 3 amps. And it won't take long till something will get warm. But yeah, you see, the module still works. And in this case, this power supply is protected internally to a maximum of 3 amps, and it will not burn out its fuse because it's software protected. But if you have a dumb power supply, like a Doepfer power supply unit, then it will just blow the fuse. Hopefully, most of the time. So, yeah, it's very likely that not only was the connector like it was likely not only reversed, but also skipped. To illustrate what I mean, normally you would go on like this, but it probably went on like this. Something like that. You get the point, right? So yeah, it's good practice to keep on checking your connections before you turn the power on, before you put it in your rack. Yeah. Well, I guess that's it for now. Let's get the Turing machine out. Thanks for watching, and see you next time.